Okay, we're on to our second video here about these fundamental identities. We just finished proving the main Pythagorean identity that sine squared plus cosine squared equals 1. We'll show you in a minute how we use this. Okay, so there's actually two spin-off identities. Okay, so let me kind of show you what's going on here, how this works. This sine squared plus cosine squared equals 1, you can actually divide all of these by sine squared. Again, if you do it to both sides of the equation, you're not doing anything illegal. And if you look at what happens here, now sine squared divided by sine squared is 1. Cosine divided by sine is cotangent. And 1 divided by sine is cosecant. So that gives me the identity 1 plus cotangent squared is cosecant squared. There, and I just kind of proved it. Now I'm going to go ahead and erase what I just did. And we're going to do one more spin-off identity. You know, before there I divided everywhere by sine. I could also divide everywhere here by cosine squared. All right, if you think about it, I'm going to, by the way, I got cosine squared divided by cosine squared. That's 1. I'm going to reorder this, by the way. I got sine divided by cosine. Sine divided by cosine is tangent. Of course, it's squared. And then the reciprocal of cosine is secant. So let me clean up my, my worksheet here. So I got two spin-offs. I got 1 plus cotangent squared is cosecant squared, and 1 plus tangent squared is secant squared. Do you have to memorize those? Yeah, you kind of do. And hopefully you do enough problems where it'll become a little easier for you. It'll become second nature. I'm just going to clean this up, make it look a little better. There we go. So you're probably thinking, hey, how do I use this? Pretty simple. So if you look at example 2 says 1 plus tangent squared multiplied by cosine. What is that? I got to tell you, whenever I see a square, I look to my Pythagorean identities. It's staring you in the face there. That 1 plus tangent squared, and I'll highlight this in green, that's the same as secant squared. We just proved that. And of course, I still want to take that and multiply it by cosine. Now, in the next step, there's a relationship between secant and cosine. In particular, cosine is the reciprocal of secant. So I can leave secant squared as it is and rewrite cosine as the reciprocal of secant. So it's 1 over secant. So I have secant squared times 1 over secant. And of course, these guys cancel out, right? I got a secant in the denominator, a secant squared in the numerator, and that cancels out to just be secant of theta. So that's kind of the game we're playing here. We're going to use these fundamental identities to simplify these. And why is there so much canceling, and why do things look nice? Because these functions are all based on a circle and they're all interrelated. So there's all kinds of canceling. There's all kinds of like weird looking algebra that goes on here. Look at 3. I got cosecant squared minus cotangent squared. This one's pretty easy because I already have a Pythagorean identity that relates the cotangent and the cosecant, right? In particular, I can take cosecant squared and I can replace it with 1 plus cotangent squared. So in place of, and I'll color code this one, I'll do this one in, why don't we do this one in purple? In place of cosecant squared, I'm going to write 1 plus cotangent squared. So I'll write 1 plus cotangent squared theta. And I still have a minus cotangent squared theta. And the cotangent squareds cancel out. Everything cancels out just 1. And so really, I've actually just proved another identity, believe it or not. Cosecant squared minus cotangent squared equals 1. You know, what did I do? I just took that Pythagorean identity and I just reshuffled the deck, right? If you move cotangent squared to the right, you get cosecant squared minus cotangent squared equals 1. So that's kind of how it works here, right? If you look at number 4, I got secant squared minus tangent squared. Well, hey, I already have an identity, and I'll write it here on the side. I have this identity that says 1 plus tangent squared equals secant squared. Right? So if I want, I can replace secant squared with 1 plus tangent squared, or I could just realize that if you bring tangent squared over, you'll get secant squared minus tangent squared. It just equals 1. So secant squared minus tangent squared equals 1. And what am I left with? 1 divided by sine. Of course, 1 divided by, that's the reciprocal of sine. That's cosecant theta. So it is pretty neat that all this stuff just kind of relates back. Let's do a couple more in this video. Here I got sine squared plus 1 over secant squared. Well, if I see 1 over anything, I think, hey, that's a reciprocal. What's the reciprocal of secant? It's cosine. So that's simplified to sine squared plus cosine squared. But guess what? That's a Pythagorean identity. That's the first one. Sine squared plus cosine squared equals 1. Arguably the most used identity that we have. So number 5 is done. Number 6 says 1 minus cosine squared theta over sine theta cosine theta. Resist the urge to just cross out cosines there. Remember, the top is a subtraction problem. You can't do that. But I see a square, so that tells me, hey, Pythagorean identities. So I'll do an aside over here. I'll rewrite my Pythagorean identity. Sine squared plus cosine squared equals 1. And again, if I reorder that, if I bring cosine squared to the right, I get 1 minus cosine squared equals sine squared. So I can kind of rewrite number 6. And the numerator, in place of 1 minus cosine squared, I could just write sine squared. You know, I keep saying sine squared. It's sine squared theta. You need to have the angle. The bottom is sine of theta times the cosine of theta. And if you notice, I do get a cancel, right? The sign in the denominator cancels out with one of the signs in the numerator. So I'm left with just sine theta divided by cosine theta. That's a fraction, that's a ratio, that's one of the ratio identities, that's tangent.